Okay, in this video, we're going to be talking about access technologies. And what we're talking about access technologies, what we mean by that is getting information from your ISP to your home, right? And the term we use for that is kind of the last mile. It comes from all over the world through your ISP and it gets to your home. So what are the different ways to make that happen? Also in this video, we're going to be talking a little bit about the backbone, how information gets all over the internet to your ISP. So we'll talk about a little bit about this, but mostly about this last mile. How it works or how information is sent is through a term, something called multiplexing. So with the word multiplexing means able to take different signals. So maybe you've got a Netflix video, an email, you're downloading a web page, and you're combining all of those different streams into a shared medium. We've talked about shared mediums. This could be a coax cable or Wi-Fi or a shielded twisted pair, right? It's a shared medium of some sort. Once it gets to the destination, it demultiplexes, meaning it takes that single strand and converts it back into the individual streams. That's what multiplexing is. So when we say, getting that last mile, what we're talking about is getting it from your ISP to your home. And when I say ISP, that means whoever you get your internet service through. So around here is mostly Spectrum and Alt Fiber, but here's some other very well-known larger ISP companies. But when I say ISP, just think of Spectrum or Alt Fiber to put it in perspective. In general, people tend to download more information than they upload. So we want to download, we want to stream a Netflix show or download a web page. We download a lot. We do need to upload, so maybe we send an email out, or maybe we're uploading a URL or a web address to the ISP in order to download the web page. So we do need some upstream, although most people download more than they upload. We have two terms that we use to describe the speed or the data rate or the bandwidth of this downloading and uploading. We have narrowband and broadband. And so we can kind of compare it to our highway systems. In the cities, where there's a lot more people, we need more lanes of traffic in order to get that people through. We need broadband in big cities. Out in the country, where there might be a road that only a car goes down a few times a day, we don't need 5 lines of highway out there. It's ridiculous. The cost to build that is not needed. So you just need a single lane. So whether we use narrowband or broadband really depends on the need and where you're trying to get the information to. So narrowband technologies, we have dial-up, which is the old phone modems that you probably aren't aware of, but your parents are. Leach circuits, fractional T1 lines, and then ISDN. We'll talk about HEREs in a minute, but I just want to talk about the general definition of a modem. We use the word modem a lot, and modem stands for modulate and demodulate. And its job is to take a standard or a way of that information is being sent on one side, say a telephone line, and converting it to a different standard that a computer or a digital system would understand. So maybe this is analog and this is digital, and the modem converts it as it goes through one system to the other. So that's what a modem does. Now, broadband, on the other hand, is higher data rates. And just so you know, when we say broadband and narrowband, there's no exact number or definition of each. It's more of a general terms used, right? If it's slower, it's narrowband. If it's faster, it's broadband. Here's some different technologies. So it uses a DSL. Hang on one second. There you go. Uses DSL, and DSL uses telephone lines again to send signals. through, and then once it gets to your house, a modem again converts those telephone standards to a modern computer network standard that your devices in your home understand. Then you have cable modems. We'll talk about T1 lines and wireless access. So here are the two different kind of options and techniques you can use to between broadband and narrowband. I will point out this T1 line here is considered a broadband. However, it is possible for companies to lease just a fraction or part of that T1 line. And if it's just a fraction of it, depending on how much it is, it could be considered narrowband. All right. All right. So another term we need to know is the local loop. The local loop is just that process of sending information from your ISP to your home and then uploading your information from home back to your ISP. So you upload a URL asking for a web page, and then you download the web page. That is called the local loop, and it's not over a great distance. It's a smaller distance. ISDN is one of those technologies that stands for Integrated Digital or Services Digital Network. And you don't have to remember what it stands for. Just remember that ISDN is an older, slower technology. You don't see it too much anymore, but it is still used, and that's why we're talking about it in certain cases that you need to know about. Then again, we have DSL. And again, DSL is broadband, right, for high-speed data. And here are all the different standards for DSL. You really just need to focus on ADSL because that is what most residential home users access or use, is ADSL. How does it work? How does DSL work? Well, it uses a standard or a process called frequency division multiplexing, or FDM. And what FDM does is it takes that stream and it divides it up into three different parts. The smallest part is your landline. This is your plain old television service, or called POTS. So this is your landline. Then there's another section for you uploading data. So sending an email or sending a URL or whatnot. Notice it's a little bigger than POTS, but it's not the biggest section. The largest section is reserved for downstreaming. So when you want to downstream your videos or your web pages or whatnot, that's what you need most of the line or space for. So because of FDM, the multiplexing, DSL and POTS can use the same line simultaneously. So whether it's a video or a phone call or whatever the data is, it can go over the same wires because of the way FDM works, the multiplexing works. Then we have cable modem technology. So this is a different broadband technique that uses coaxial cable. Again, it uses FDM to deliver many channels, many cable channels over the same coax line. Now, here's the thing with cable modems. Yes, it's considered broadband, right? It's considered broadband. But this bandwidth is shared amongst all of the people that are connected to it. So here's a street that has a coax cable going down. It's using a cable modem. And all these houses are sharing that same data rate on the same cable modem. So here's the problem with that. The houses at the beginning of the neighborhood will get pull in and use a lot of that bandwidth. And then by the time it gets to the end of the street, there's not as much bandwidth left. So houses down here could have some connectivity issues. And I know this because years ago we had Spectrum in my house and we lived on a cul-de-sac. And between 7 p.m. and 10 p.m., kind of peak TV hours, right? We'd be watching TV and all of a sudden the show would pause. And you can see it's very frustrating when you're trying to watch a TV show. So we stopped using Spectrum in their cable modem, and we switched over to Alta Fiber, which used DSL at the time, and now Alta Fiber has fiber optics coming to our neighborhood. So we have no connectivity issues anymore. But that is one of the downsides of the cable modem. So cable modems and really a lot of things in your, a lot of standards that send signals to your house have to use some type of modem in order to do the multiplexing. So if you look in your house, every house has some type of modem. And what the modem does is it takes the signal that comes into your house, either through coax or Wi-Fi or twisted pair, or however it comes in, phone line, telephone phone line, and it converts it from that signal into a digital signal that your network understands, that your laptops or maybe it's a wireless signal understands. So how it travels over the wire, whether that be a phone or coax, is different than how it travels inside a network. And the modem converts it from one standard to the other. We do have like a hybrid cable that uses both coax and fiber optic. And the fiber optic is used for higher bandwidth needs. And then the coax is used when a slower rate can be used. And again, we're talking about I want to talk about this term trunk here. That's getting it from the ISP to your neighborhood. So here's your ISP, and it goes to this trunk in your neighborhood. And here's another trunk to another neighborhood. So this is typically higher speed, and then down here to your house is typically coax cable. Although it doesn't have to be, but I just want to point out that the term trunk is kind of a way to break down a big city into smaller parts. So using fiber, we have a lot of different ways to use fiber. We can have fiber from the ISP to the trunk, and then from the trunk using coax cable into your house. Here's one option. Or we can do fiber from the ISP to the curb, right outside your house, and then it coax from the curb into your house. Another option is to do fiber optics all the way to your home. Now, a lot of times this is used in businesses, right? So you have fiber to the building of a business. You can do it to your home, although that's a lot more expensive. And then you could have fiber all the way not only to your building, but through your building. And you just use your copper wires, your shielded twisted pair, from the wall to your device. So what you do, which method you use really depends on the need and the cost. As you can imagine, the more fiber optic you use, like into your house, is a lot more expensive than just getting fiber optic to the trunk for your neighborhood. But getting fiber into your house is a lot faster than just to the trunk in your neighborhood. So you got to decide what your needs are. This slide kind of goes into detail of what I just kind of explained. Here's the fiber to the trunk for your neighborhood. Oops, sorry. Here's the trunk fiber to your curb, and then copper goes into your house, and here's fiber all the way into your house. And you got different standards depending on your needs. So how does it get from the ISP into your house? And what kind of standards or frames does it use to send it over fiber optics and the cable? Well, they use modems, right? We've talked about modems. In your house, you have a modem. They call it a tail-end modem because it's the end of the line for that data that converts it into a stream that your network understands. On the other end, you have the head modem at your ISP. This is where it starts. So your ISP has a bunch of information coming in from the backbone, and it converts it using a big contraption like this. This is the head modem. It's huge. That's able to take lots of information and convert it into a data stream that fiber optics and or a telephone line will understand. So this is the head modem, and then your house is the tail modem. The data format is called DOCSI, which stands for Data Over Cable System Interface Specifications. You do not have to remember what it stands for, but just remember that DOCSI is the data format that ISP use, that modems use to convert to transmit the data. Besides the cable, we also have a broadband technology that falls under the wireless category. So, let's just say for a second, let's take a look at the map here. Here's Hamilton County, and if you live anywhere in Hamilton County, or maybe even, on the fringes of Butler, Warren, or Claremont, these are all really developed areas and where there's a lot of people, and they've put broadband technologies around here. But what if you lived on the fringe of Claremont or even Brown County? A lot of farmland, not as many people. It's not, financially advisable for ISPs to spend a lot of money to get broadband out to these areas where there's only a few customers, using wires, right? Using fiber optics or coax. So what a lot of them do out there is use wireless technologies to connect and get higher speeds of data. We've talked about satellite connections already in the past. WiMAX is another version of wireless that kind of uses satellite. We're not going to talk about wireless today. Just know that satellite and WiMAX are wireless standards. Then 3G, 4G, and 5G, these are typically cell phone connections, right? 3G phone service really is not used much anymore. Most of our cell phones connect either using 4G or 5G. We're going to talk about cell phone technology in a different module. So I won't go into the details here, but just know that all of these are wireless connectivities. So in order to connect to rural areas, we have to use wireless connectivity. And in some suburban areas, DSL really doesn't work for various reasons. So we use some wireless technologies sometimes in different parts of cities or suburbs. Okay, so now we're going to switch gear, and up until now we've been talking about different ways that the ISP gets the data to the home, that last mile. Now, the next few slides, we're going to be talking about how the ISP gets data from the internet through the backbone. And when we say core, that's another name for backbone. Backbone core is just huge lines that take huge amounts of data. So how does that work? Well, they use either kind of point-to-point digital circuits or high-capacity digital circuits. The key term there is a digital circuit. Telephone lines, or telephones, have been around since the late 1800s. It's a really old technology. Modern computers and modern networks, right, LANs, use modern technology. So we need a piece of equipment that is able to translate digital streams, right, used by the phone company into a format that modern day computers understand. And so that piece of equipment is called a DSU-CSU, which stands for Data Service Unit, Channel Service Unit. I don't think you need to, again, remember what it stands for. Just remember that DSU and CSU is that piece of equipment that's able to take a signal or data from a network. So maybe this is your home and you want to send an email, or you're sending out a URL to request a web page through your router. The CSU, DSU converts it to a standard that phone lines understand, the older technology, and it can go through the backbone now very quickly until it gets to its destination. Then there's another CSU, DSU that converts it from this old telephone standard back to a modern computer standard that the router understands, and then it goes into your network and your destination computer. So here in the middle here is kind of what we're talking about, the backbone. So here we go, again, digital circuits, right? Use the same standard that phones use, that telephone use. One of the common standards is called a T1 line. So you have all these different standards, T1, T2, T3. Don't ask me what T stands for, they just use that. But a T line that can take up to maybe 24 different streams, right? We would consider that a broadband technology. This is where it gets a little tricky. If you recall, I said companies could lease a part of or a fraction of a T line. And if it does, depending on how much what part or what fraction it uses, it could be considered narrowband if it's a fraction of a T1 line. If it's a full T1 line, it would be considered broadband. So now, how do we kind of send that signal over the T1 line? Well, there's a digital signal level standard, or DS standard, that uses multiplexing to combine together phone calls and other signals into into one connection. So combining all those different signals into one stream is called is the DS standard. Now, T1 and DS1 are often, those terms are often interchanged. So we'll use the term T1 here in this video and here in this class. But just know that, DS standards are also the process of how T1 lines are used. We're getting back to the this version of trunk, or this definition of trunk. If you recall, a trunk is getting information from your ISP to the neighborhood. So this next slide here, we're going to be talking about this section right here, getting it from the ISP to the trunk, and this is high speed, right? So that's what we're talking about here, using these different standards. So the synchronous transport signal, so STS, again, I don't think you have to remember what it stands for, but just remember STS gets the information from the ISP to your trunk in your neighborhood. And if it's TST, we're referring to the copper, right, the coax cable. OC stands for optical signal, right? That is using fiber optics. So whether we're using coax or fiber optics, there are similar standards that have, different names and different techniques. But one is for copper, the other one is for coax. One is for copper, the other is for light or fiber. So the last kind of system that we use in order to get it through the backbone of the internet is called synchronous optical network, or SONiC. And SONiC is just a standard that is used to connect transmission systems that use different rates of speed. So, it says, hey, if you're going to go over the phone line on the backbone, your data frame has to look like this. And it says, okay, if you're a lower capacity, I'm going to connect you to a higher capacity circuit. So maybe it's, connecting from ISDN to a T1 line. And SONiC helps that conversion. You can kind of think of it, SONiC, as like the rules on the interstate highway, where we have exit ramps and entry ramps to get on the highway and off the highway. We have speed limits. We have rules that no horses are allowed on the interstate. So kind of SONiC is just the rules that are used to get information down the backbone of the internet. All right, so make sure you look over these terms and you kind of understand what they mean. As always, if you have any questions, hit me up in class and we'll try to explain it for you. Good luck to you.